Thank you, and thanks for that kind introduction, Alejandra. It's really nice to be here. This is work that is brand new to the world. It is also an area of research that is new to me. As we were talking last night, you get involved in these panel studies of education, and it turns out that those folks get older. And so you sort of study how that happens. And so I've gotten into this line of inquiry that's going to take me, I think, into Alzheimer's disease and related dementia work. This is a big group science project. These are the current suite of co-authors. Subin Kin and Michael Culbertson are research scientists on our project at Wisconsin. Chandra Muller at UT Austin, Rob Warren at Minnesota are my longtime co-conspirators and collaborators. Jennifer Manley and Adam Brickman are both neuropsychologists at Columbia University, relatively new additions, but absolutely critical to this work because they actually know stuff about Alzheimer's disease and related dementias. For those of you who are graduate students, one of the things I absolutely love most about this line of work is that you get to get paid a decent salary and basically be a postdoc and learn from people like them. So it's sort of amazing. So this is a very descriptive project. So the primary goals here are going to be to quantify the association between education and cognitive function as people approach around age 60. And what I really am pushing for, what we're pushing for, is to understand what education does and does not tell us, and what it is about education that may be related to where people are in their cognitive function as they approach age 60. In particular, we want to think about the potential contributions of educational opportunities and educational achievements, two distinct things in education that adolescents experience, and how those things may contribute to patterns of cognition as people approach age 60. And this is going to bring me to talk a little bit about variation both between levels of education, by which I'm going to mean degrees or credentials, and variation within levels of education that are related to these adolescent educational opportunities and educational achievements. I should also say, I don't know what the norms of your seminar are. I'm happy to defer to them. I'm happy to have questions as we go. Whatever works for folks is fine. So just by way of background, why is this important? Almost 1 in 10 people in the US who are over 65 years of age has dementia, and another 22% have something called mild cognitive impairment. Mild cognitive impairment turns out to be this sort of vague-ish notion of cognitive decline. It's not quite as rigorously operationalized as Alzheimer's disease and dementia, but is an area of serious concern as the population ages. So there are countervailing trends that are relevant to our understanding of the sort of population distribution of Alzheimer's disease and related dementias. On the one hand, the prevalence of dementia, measured over here, is declining over time. And this may, in fact, be in part due to changes in the educational composition of cohorts as they age. Could be in part due to other enhancements in population health. Whatever it is, the prevalence, whether you're looking just strictly by age or you're looking by sex, is declining of Alzheimer's disease and related dementias. So that's good news for all of us. Also good news for population health. On the other hand, as all of you probably know, our population is aging. And so those 65 or older who are at increased risk of Alzheimer's disease and related dementias, that population is growing. So what this means, and I've lifted this from a recent publication, the Journal of Economic Literature, is that the amount of money that this consumes, and this is direct healthcare costs. This isn't even the costs that are borne by relatives of those, some of you may have experienced with this, relatives of those who are becoming demented, relatives of those who are suffering from Alzheimer's disease, the care that they give, all these things, right? This is just the cost of care that's monetized. Direct cost of care goes from about 5 million the peak will go from 5 million to 14 million. The cost of care are about 159 billion and will be increasing over time. So that is all to say that understanding cognitive change over the life course, and particularly as people age into higher risks of Alzheimer's disease and related dementias, turns out to be really important. So you may wonder, when does this cognitive decline begin? Bad news. Turns out it begins fairly early. Probably most of you in this room have already begun your slow downward descent. So this is 20 years of age up to 90 years of age. And so this is word recall. And so this sort of declines beginning in our mid-20s. Other aspects of cognition, verbal fluency, for example, maybe persist until our 30s, 40s, and then start to decline. That decline increases in rate over the life course. And this is a really nice, if you haven't seen this paper, Yang, most recent Yang production, looking at life course trajectories and cognitive aging. Very nice piece going across multiple studies to try to estimate the change in cognitive function over the life course. So that's sort of why we should care, why we're interested in this bigger set of puzzles. This is the education, one snapshot of the educational differentials in that, with people with high school or less down here in yellow, people with college or more up here in green. And you can see, one, cognitive aging happens to the population, whether you're college educated or not. Two, folks, not surprisingly, who have more education start off at a higher level and may decrease at first at a slower rate. Now, the science on this is sort of mixed in my view. There's clear science that says, okay, there are differences in cognitive function as we approach midlife, late life. On the other hand, whether there are differences in the slopes and the decays of cognitive function over time still remains sort of an open question. Some folks find, yes, there are. Some folks find, no, they're not. So that's all by way of background. I want to emphasize today, I'm talking about a cross-sectional snapshot of that. So we're looking really at people around the ages of 57, 58 years of age, approaching 60. And so I'm not going to tell you a story about the trajectories of decline today. I want you to focus instead on where people are as they approach 60 and on the roles that educational opportunities and achievements may play in shaping where they are at that point in the life course. So I'm a sociologist of education. That's kind of been my bread and butter. That's really why I got into this line of work. As I mentioned, all the aging stuff is relatively new to me, I suppose, both subjectively and research-wise. So I think a lot about schools and schooling. I think a lot about educational opportunities and experiences, about educational outcomes. And I think that's kind of what Rob, Chandra, and I bring to the table in this work. So there's been a lot of work on school quality, and I put it in quotes not to be snarky, mostly, but because like there's a lot of variation in what people mean by school quality. And I think there's a lot of sort of, here are the measures we have, they're quality-ish, and so we're going to consider those school quality. So one example of this from study by So et al. And Avila et al. Use a lot of the same measures, is looking at state-level measures of educational quality. And by that, So and colleagues mean lower student-to-teacher ratios that you can read from administrative data for earlier cohorts, higher average school attendance rates, and longer term length. All of these aspects of school structure seem to contribute to lower risk of dementia at ages greater than or equal to 65. And in their case, they're looking at a Kaiser study in Northern California of about 21,000 folks using administrative data. Another look at quality focuses on sort of composite measures. And so here, Cisco et al. Are looking at this Washington Heights Inwood Columbia Aging Project. This is a fairly well-known YCAP. It's a fairly well-known study in New York. And so they're using these measures of early life educational quality. Those include the percentage of white students in primary school. These are all reported by sample members in YCAP. So what percentage of the students in your elementary school were white? Did you go to an urban school? Did you have a single classroom for all grades? And then administrative data on length of school term, again, as a measure of exposure to education. And sorry, I haven't quite accepted that I need these yet. So I'm still in the reader phase of my gradual decline of my vision. Length of primary school term, average school days attended in primary school. Again, this is an administrative record and student-teacher ratio in primary school. Okay, so that's sort of, they put all these things together and proxy school quality that way and find that that predicts general cognitive performance and executive function for Black sample members, but not for white sample members, right? And so this leads them to sort of speculate why that might be. And then one that strikes close to home for those of us with the Wisconsin roots, the Wisconsin longitudinal study. Here, the school advantage is, again, a mashup composite where we're looking at academic year length, average attendance, student-teacher ratio, all these things. And these predict fluency and executive function. but not memory in this particular test. So this is how people have approached school quality in this literature so far. They're really thinking about what measures can we get retrospectively from for people in their 60s or older about their school experiences, and what can we get from administrative data that might be related to school quality. I would argue these are relatively crude proxies of the things we might mean by school quality. They're sort of representations of structural constraints or opportunities that students confronted in their early schooling years, but not necessarily the things that if you were thinking about, like for your own kid, what constitutes school quality, you might not think about sort of the length of the semester, right? Doesn't mean it's not meaningful. It's an exposure, but it's not necessarily school quality. So here's how we're thinking about this right now. And again, would love your thoughts on all this stuff as we move the project ahead. So educational opportunities we're thinking about is the place that we could most likely intervene. If you think about educational policy as health policy, which many people want to do, where is it that we could pull a lever? What could we change? So course availability is one thing that would be structural. Do you have calculus courses? Do you have physics courses at your school? School quality here, again in quotes, because you'd really have to think carefully about what it is you mean by school quality. There are all sorts of dimensions to school quality. Teacher quality is another one. In the education literature, we like to think about the things that adults do in the classroom, the teachers do in the classroom, the structures, the sense of belonging they can inculcate in students as dimensions of quality, but those are awfully hard to observe and measure. School climate's another thing you might want to think of. The important thing about educational opportunities is that they exist whether or not students take advantage of them. That is, they are out there. And so I want to really make a clear distinction between the opportunities students confront, the choices they make, and the constraints that may shape how they make those choices, right? Opportunities are things that we can provide, that we can make available to varying degrees. Educational achievements are the things students learn, the skills that they have at the end of this educational process or some educational period. And these are products of opportunity and effort. They're not free of the effects of social background, so I'm not trying to convince you that this is just this pure thing and anything that they get because they work for it. No, that is not what I'm saying. What I'm saying is the concept of achievement is very different from the concept of opportunity. It is what you have at the end of the day that is shaped by a variety of things, including a student's privilege, a student's deprivation, family circumstances, exogenous shocks. If you had a kid in school in 2020, you know exactly what I mean by that. Exogenous shock. Educational credentials is what we normally have looked at. This is what a lot of the literature looks at in terms of the gradation of cognitive function across levels of education. And that's basically an exposure. It reflects achievement that's due at a minimum to persistence, but it doesn't necessarily reflect how well you did in school, what you learned in school. You know, as all of you know, it reflects that you could stay there that long. And there are things that go into that. It's easily observed and reported across the life course, which makes it awfully useful for educational and cognitive research, especially with aging populations. How much school did you get? What was your highest degree? People can reply and have fairly reliable estimates. It is certainly in part endogenous to opportunities and achievements and advantages earlier in life. It may be in part due to luck. It is one realization of what we perhaps should mean by education. That is, educational credentials or degrees are meaningful things. But it is one realization of this underlying set of processes that we should care about if we want to think about how is education related to cognitive health and aging. So today, I want to evaluate educational gradients in a couple of different cognitive domains for a naturally representative sample, as that sample approaches age 60. And I want to call your attention in particular to the overlap in the distributions of cognitive function across levels of education. I think we don't pay enough attention to how much these things overlap or to the errors in our estimates. We often look at just a sort of point estimate of educational levels and cognitive function. I want to really push you to think about how much these things overlap. I want to quantify the potential contributions of high school educational opportunities and achievements. So first, variation in cognitive function across levels of education. And second, variation within levels of education. Another thing that people in this area haven't thought much about is a college degree, a high school diploma. Those are not just one thing. There's a distribution of skills, of achievements within any of those. And those may be important for us to understand if we want to understand cognition over the life course. So briefly, A little bit about data. The U.S. Department of Education has launched a series of panel studies of cohorts of students in high school or in middle school. This is high school and beyond. This is the cohort I'm going to talk to you about today. This is a nationally representative sample of folks who were in high school in 1980. They were either sophomores or seniors in that year. There's another study that will be like, this is like our big science study. This is going to be our bigger science study because this one has MRIs. This one's going into the field in January as a sort of, I'm not supposed to call it a pilot, but I always forget the thing I'm supposed to call it, so I'm going to call it a pilot, of about 250 folks. It's the high school class of 1972, and the actual sample size will be, the target sample will be around 12,500 of them. And so we'll start off in the field in January, and then that'll roll through the next year and a half. So stay tuned for that. Don't have data to share with you yet on that. I'm going to talk to you about high school and beyond. Some of you know these data quite well. Some of you perhaps not. This was initially a stratified sample of 58,270 students attending 1,020 high schools in the United States in 1980. They were sophomores or seniors, so that would mean they were 16 or 18 years of age at that time. A panel of about 26,830 of these students were selected to be observed over time. And so they were surveyed in 1980, 82, 84, and 86. And then the sophomore cohort only surveyed again in 1992. Another little kernel for those of you who are graduate students moving your way up. So what happened was, as often happens, Chandra, Rob, and I were enjoying a few beers at a conference. And this idea came up of like, wouldn't it be great if we could follow one of these panel studies? Which one would it be? Well, high school and beyond seems like a good one. Maybe we should look into that. That's where this started at the American Educational Research Association conference. So, you know, chance to have a beer with a friend at a conference. Do it. The seniors were followed up in 1982, 84, and 86. And so the 92 and 86 points are where the U.S. Department of Education is done with the study. And so the study just sits there for a long, long time because as far as the Department of Education is concerned, they look about 10 years after high school and figure, okay, that's labor market entry, family formation, boom, bada bim, we're done. Somebody else is thinking. So we came back in 2014 with the sophomore cohort, 2015 with the senior cohort. That would be when they're about age 50 and 53. And we managed to get about 62% of those folks to respond to surveys at that time. The new wave of data, which will be, we're actually sending the data to the U.S. Department of Education next week. So they should be available in the next year, year and a half, depending on how long that whole process takes. We went back out in 2021. They're about 57 and 59 years of age. And we got about 58% of them to participate in this study. We did cognitive assessments. We did interviews with them. We did health visits where we asked their permission to do blood draws. And then most of them complied. We still have blood draws. We have saliva for the oral microbiome. For DNA, we haven't done the DNA stuff yet. And we have administrative data linkages. So there's a ton of stuff. I'm happy to talk to anybody about the resources that are available in these data. The cognitive measures are sort of the focal point of today's talk. We went out in two modes, web and phone. In the web version of the survey, we did two paired associates tests where sample members are given a series of pairs of images. So it could be pairs of words, 5 seconds between each one, or pairs of images. So two barns, two bathroom fixtures, pairs of these. And then asked to recall the right ones after they're presented with these. So you'll get the two pairs of barns, and then about 2.5, 3 minutes later, there's one of the barns, and here are 4 other barns. Which one matches? Okay. These are taken from the Test My Brain project by Laura Germain and colleagues. On the phone, these are part of HCAP, which is what Harmonized Cognitive Assessment Protocol. The Health and Retirement Survey uses these. A number of international studies use them. So there's a 10-word recall task. The CRAD words, you read the words, then you're asked, please recall as many of those words as you can. 5 minutes down the survey, after a delay, you're asked to recall them again. A forward and backward number span task, 2, 3. Please repeat those digits to me, 2, 3, and the backward would be, you say 3, 2. And then letter fluency is how many F words can you list in 60 seconds. Please start now. Animal fluent or phonemic fluency is the animal task. How many animals can you list? Some of you may be wondering, and I did, so I looked it up. How many respondents list that F word? Because like that's the F word that would pop to my mind. It turns out 55 of them did, which made it the 264th most common word. And some of them you could listen. Some of them were like very self-conscious, like, well, there is another word. So we're going to talk today about the phone tasks, not about the web task. So in terms of design, the web survey had about 8,860 respondents. The phone survey about 4,430 respondents this time around. One of the things that we did to try to maximize the number of people and the distributions of folks in the phone battery, because we have more confidence in those cognitive assessments, is we took 25%, a random 25% of people who did well on the visual and verbal recall, and we asked them to do just the CATI cognitive piece, the phone cognitive piece. And then everybody who did poorly on these was sent over to the cognitive tasks on the web. I'm sorry, on the phone. And so at the end of the day, we have about 6,230 people who have completed the cognitive assessments. We're going to drop, for the analyses I'm going to show you, we're going to drop about 570 of those folks who wrote things down. So we asked them at the end, did you write anything down during that test? And 507 were like, yeah, well, as a matter of fact, I did. So it turns out, this may not surprise you, they did quite well on the assessments. So we're dropping them from these analyses. A little bit on measurement, because this is where my head has been for like the past 6 weeks.
Sorry, Aaron,
Yeah, please.
like, which 570? Or like, is it are they a really selected group?
Are they a really selected group? I haven't looked at other demographic or background things.
That were writing stuff down.
Not to the best of my knowledge, but that's a good thing for me to check. I don't know anything about them other than they wrote these things down. I will check it. So how are we going to measure cognitive function? So for things that were correct or incorrect, like the CRAD word list and recall, we're going to use a 2-parameter IRT model, item response theory model. This is basically logistic regression, where you're predicting the probability that somebody gets a particular item y sub j right equals 1. And that is a function of theta, the underlying ability that they bring to this task. Alpha j is going to be the slope. That's how discriminate this particular item is. Steeper is more discriminate. And d sub j is really, in this, the way this is written, an easiness parameter. So it locates the place on the theta distribution where this does the best measuring. Really, it should be about the place where 50% of the people get the item right, 50% get it wrong, the point of inflection. So for the fluency items, naming the F words, naming the animals, there isn't a set of right or wrong answers, so you can't do it that way. The way the test was administered, the number of responses that are admissible is broken up into 10-second bins. So each person should have 6 bins for the F task, 6 bins for the animal task. And we ended up using a graded response model or an ordinal logistic regression model. Same setup, except here we have D, J, K, where K is a cut point. And so there are different points on the distribution where you tip over to be more likely to get that category correct. And we played with Poisson models. They actually ended up not fitting as well. So we did this ordinal logistic model. Okay. Each item loads on a single latent factor, and the factors are free to covary. And so there's no overlap in like the word recall does not tap the phonemic fluency thing. And that was really model driven. So those were the best fitting models. We also combined immediate and delayed recall based on model fit. They weren't very distinguishable. The forward and backward digit span also, they were correlated about 0.85, the 2 factors. So they weren't very distinguishable. We combined them. And what I'm going to talk to you about today is just the empirical Bayes estimates for these cognitive function measures. You could also, we have plausible values that we've generated too. I haven't played with those yet, but those would do a better job of capturing the errors involved in these. For now, you're just looking at the empirical Bayes estimates. Key predictors. So highest degree attained from the 2021 survey. categorized as high school or less, some college or an associate's degree, combining those two, some college and associates. Bachelor's degree and a graduate or professional degree. It turns out people do continue to get education over the life course. So if you took the early waves, you'd actually miss some of the action in that. Educational opportunities. Today, I'm going to talk to you about a set of measures that we have in there. I'll talk at the end about some other stuff I might want to put in. First are from principal reports. So in 1980 and 82, principals at the high schools were surveyed, and they were asked a number of questions, including whether the school offered a calculus class, a computer programming class. They were asked on an ordinal scale to estimate the distance between the high school and the closest four-year college, the high school and the closest two-year college. They were also asked the share of students who graduated in 1979 who went on to college. So these are all subjective perceptions of the principal. They all turn out to be predictive of some things, not necessarily in these models, but so they're imperfect measures, but they are, I would argue, measures of the actual opportunity structure students might have confronted at a high school, not the things that the students did or didn't do. And then we've estimated really simple school value-added models for 3 test scores. All the students in the sample would have taken these standardized assessments as part of the survey in 1982. So we're looking at their performance on vocabulary, reading, and math. The simplest way to think about this is, what is the average growth for kids in that school in vocabulary between sophomore and senior year compared to kids in other schools? It is, in fact, in this case, a regression of the senior year score on the sophomore year score on race, ethnicity, and on sex, and that is it. And it is a random effects model where there's a school random effect. That is the value added. In this case, it looks almost identical to just an average change score for the school, standardized across schools. Yes?
So this whether calculus variable, that is whether the school they went to in high school offered calculus?
Yes. Not whether they took.
Do you observe whether the student took calculus?
I do.
So, I mean, there's a question about whether this is all selection based on neighborhood characteristics, right? Or whether there's a causal effect of the course you take. You know, if conditional on whether the school offers calculus, whether you take it doesn't matter, to me it would suggest that it's about selection, not about causal.
So you're talking about selection into the high school.
Yeah, I mean,
Yeah.
different people live in different
Yeah.
areas.
Yeah. So that could totally be true. There are 2 things I'll say about that. One is in the school value added world, people tend to think about what the adults in the school can add, but we also know in social ed that like there's a ton that comes from peers. So I'm not sure how much I want to take that apart. It could well be you happen to be in an advantaged neighborhood. And then there's a separate component, which would be your advantage. I'll show you, I will condition on an SES composite. We've also looked at parental education, family income, parents' occupation as the individual level measures. Those turn out not to matter all that much.
I would just think there's like sufficient societal interest on whether certain types of activities can prevent dementia, right? So
For sure.
Right. It'd be interesting to know whether taking calculus does that.
Yes.
Or like music lessons or
Yeah.
whatever. Right?
Yeah. 100% agree with you. Yeah. And one of the next pieces of this project is going to be, how can we get a relatively convincing causal estimate out of these data? That's a whole other, like, as you probably know, tangled ball of yarn. Jeff Wadke and I have talked a little bit about how to approach this problem, but the descriptive stuff will come first. But I totally agree. Yeah, at the end of the day, it's what you want. Educational achievements are going to mean for us the standardized achievement test scores students have in reading comprehension, vocabulary, and math. And that will be in their senior year of high school. The sophomores would have taken these tests twice, seniors would have taken them once. Also self-reported grades. So we're going to take it was an ordinal report. We're just classifying to the midpoint of the ones that are under all A's. All A's will just be 4.0. So we're quantifying that. And then controls, I will have race and ethnicity, sex, and an SES composite. I will say, I kind of hate SES composites in general, but given that I just wanted to try to clean things up a little bit for this presentation, that's what I'm showing you today. Better models won't make much of a difference, but that's what we've got today. So we multiply impute predictors in this model. I'll show you something about the missing data in a moment. There's not a ton of it. We don't impute the outcomes. Kernel density plots, I'm going to start with some kernel density plots just to show you the curves of cognitive skill distributions by degree at age around 60. And I'm going to give you an estimate of the overlap in those distributions. And I'm going to correct all those for test score reliability. They're fairly reliable. I'll show you that in a moment. Then I'm going to show you some OLS regression results, regressing cognitive skills on educational opportunities and achievements. I'm really not going to focus much on the coefficients of the predictors. I'm going to be talking to you about the extent to which these account for within and between educational credential variation in cognitive performance at around age 60. The model variance explained, I'm going to adjust, and I'm going to adjust for that based on the reliability for the 2021 test scores. That's basically going to be dividing the R² for each one by the variance in the empirical base estimate. It turns out the variance in the empirical base estimate is the reliability of the scale, and here you have the reliabilities for word recall, number span, phonemic fluency, which is the F words, semantic fluency, which is the animals. I'm going to focus on the word recall and the phonemic fluency measures today. Okay. Missing data, like I said, we don't have much. 4%, 3% on the school value added. These are slightly higher for test scores. And the reason is that some of the sophomores didn't take the test their senior year. I think we have pretty good imputations because we impute those from the sophomore test scores. So that's sort of the missing data distribution. So for our word recall and our phonemic fluency, you'll see it's about 0 at the mean by design. There's standard deviations for those. We have a nice spread of educational credentials, so we'll be pretty well powered to think about differences across levels of educational attainment from high school or less on through graduate and professional degrees. I'm a big fan of distinguishing between graduate and professional degrees in college. That turns out to mean a lot, and it's meaning more as more people are going into this graduate and professional level of education. Bunch of descriptive stuff. I'll just call your attention to the school value added measures. On average around 0. Again, that's random effects by design. And the standard deviations are a bit higher for math than they are for vocabulary and reading in terms of school value added. And then there's the achievement test distribution. They were nicely standardized back in the day, so standard deviations about 1. Okay. So here is the credential gradient in cognitive test scores at age around 60. And it's not trivial, right? And nothing about this should be terribly surprising to you. People who got high school or less are about 0.2 units, and the standard deviation of this is around 0.8 to 0.85. So these aren't, you can't think of these as standard deviation units. You can inflate them slightly if you want to think about it that way. So about 0.2 lower than some college for the high school or less, and then about 0.24 higher for the graduate and professional folks. So the range on these is about 0.44. So there's a decent range on word recall. It's actually a bigger range on the fluency tasks. So the F words and the animals, about 0.76, 0.78. So there's some action there across the educational gradient. And these point estimates, like for the word recall, that's not dissimilar from what people have found with the Wisconsin longitudinal study. I haven't compared the other ones, but that when I saw a paper, I think they're pretty close. Okay, so this is about where we are. The corrected R² is about 4% of variance for the word recall, closer to 13 to 16% for the fluency tasks, which is kind of interesting. And I don't really know what to make of that yet, but I will ask Jen and Adam what to make of it, and they will tell me. So here's the distributions. These distributions overlap a ton, right? And so here's the high school or less group in gray at the bottom. Here's a graduate or professional group, the stash line at the top, right? You can tell that from the R². I think it's useful to see it, though, that like most of the action is not across levels of educational attainment. Getting a higher level of educational attainment puts you in a more advantageous distribution, but it doesn't necessarily mean that you're going to do a ton better than somebody with a little less education. And so here's the percentage of overlap. This is based on assuming these are normal distributions, which they are clearly not. We also normalize the distributions to check that, and they're like 1% off. So these are pretty close. So the high school or less and some college folks, like the distributions overlap 91%, right? Most of the mass of those distributions is shared. Okay, so again, it's better to have the more education, but at the end of the day, it's not deterministic in any way. If you go to the extreme, the high school or less versus graduate and professional school, 80% of the mass of that distribution overlaps. you look at the phonemic fluency, there's a little more separation, but again, the overlap in the distributions is quite appreciable. So there's a lot here left to be explained, could be associated with educational opportunities achievements, could be orthogonal to those things, right? And most research today hasn't done a very good job of taking those two things apart. And that's what we're trying to do today. Another way you can think about this is if you think about the typical person. So think about the typical person with a lower level of education, say high school. What share of those with a higher level of education, say some college, would you expect the typical person to outperform? That is at the median for the lower distribution. What share of the higher distribution falls beneath it? Turns out to be fairly appreciable. So here are just box plots for the recall task. And what I've done here is just like, here's the median of the box plot is in the blue. And then I reproduce each median in the next category in black. So you can see the share of that distribution that falls beneath it. So the typical high school or less person, for example, will outperform about 36% of the folks with some college education or an associate's degree on recall and on phonemic fluency. And if you go to the extremes of those categories, it turns out the typical person who got high school or less will outperform about 1 in 5 people with a graduate or professional degree on their recall task, about 1 in 4 on the recall, about 1 in 5 on the phonemic fluency. Okay, so that's the overlap in these distributions. So what role do high school educational opportunities play in this process? So when I talk about variance in education coefficients, I'm literally just taking the variance across those coefficients, including the zero-sum college people. And I'm using that as sort of a gauge of like, how much could I account for the differences in expectation across credentials? Once I account for the fact that students have different levels of educational opportunities. And so it turns out with opportunities alone, I can account for about 20% of the variability across those levels of degree attainment. Once I add achievements, grades, and test scores, it turns out 3/4 of the variability across those levels of educational attainment seem to be accounted for by those attributes. 85% in the case of phonemic fluency, which suggests to me that a lot of this is written out in students' futures by the time they finish high school. That is, it doesn't mean that the credentials don't matter at all, right? But it means that a lot of the action, and this is necessarily surprising, a lot of the action in those credentials is based on the academic achievement attributes, the skills students had when they finished high school. Okay, that's the between level. But it also turns out that within levels of education, these attributes also matter. There's a lot more variability, as you saw, within levels of education, right? But if you take, for example, the contribution of opportunities to variance in the residual, basically from a regression of each skill on credentials, turns out you can get, 1.5 to 3% based on opportunities when we're talking about word recall, and an additional couple percentage points once we factor in achievement attributes. And then the demographic attributes, which includes SES, race, ethnicity, and sex, turns out to add a little bit more on top of that for word recall. Okay, so achievement adds to the story, demographic attributes add to the story, but there's still a tremendous amount of variation left to be explained within levels of educational attainment. Phonemic fluency seems to be more responsive to these educational opportunities and achievements than does word recall. And in particular, achievements add a great deal to this story. It's also interesting to me that we do a better job of accounting for variation among those with higher levels of education, particularly with the inclusion of attributes of achievement, right? So once you add grade point average test scores to this model, it turns out you've accounted for about 20% of the variation in the phonemic fluency scores of people with higher levels of education, about 11% with lower. Yes?
Are those approaching the maximum with dummy variables?
Similar.
Are those percentages close to the maximum which you can achieve by putting dummy variables to high schools?
Well, these aren't dummy variables.
No, you're not. But if you did, you could. The dummy variable will explain the most of between school variations.
Achievements are measured for kids, not
Yeah,
for
those-
schools.
Those are school. I thought the first two.
Opportunities are schools.
Sorry.
Yeah.
Sorry. The
The first two.
Yeah. So
I'll also say the opportunities include the school value added, so they're not dummy variables. They're interval ratio measures. I don't know how to answer that question, other than to say there are interval ratio measures in there. But maybe
but those are school-based, right? And this.
for the opportunities they are, for the achievements they're not. The achievements are individual. Yeah. Oh, I see what you're saying. Right, because I've got like 1,020 schools. There's only so, yes, I take your point. I don't know. I appreciate you asking, and I will have to ask you more about that. Okay. Yes.
Can you set up a model where you're actually getting these numbers? Like, is it? I don't know, is it like a random intercept?
Oh, sorry. The functional form of these models is least squares regression. So these are OLS models. Is that what you're asking?
Yeah.
So these are OLS models with, let's take phonemic fluency.
How are you partitioning those then? Between...
Oh, so I'm taking literally the variance of the coefficient, the credential coefficient. That's my between. Within, I'm predicting the residuals, and I'm regressing those residuals on, say, opportunities. And I'm saying what share of the variance in the residuals, correcting for the reliability of the test scores, is associated with variation in opportunities. Is that clear?
Yeah.
Okay. Okay, so what do we learn from this descriptive exercise? One, nothing new. Educational gradients in cognitive function are pronounced as people approach 60 years of age. They do vary across tasks, and the between education variance is dwarfed by the within education variance. Education matters, education is far from deterministic. These gradients are largely determined by the end of high school. The between gradients in particular are largely determined by the end of high school. The measured school opportunities contribute a little bit to these gradients, and I want to emphasize measured because we're limited by what we can measure about school opportunities. So there are more things that I'll talk about. A few. There are more things one would want to know about schools than we have to share with you, although the school value added should be helpful in this respect. Educational achievement, on the other hand, contributes a lot to these gradients. And the variability in phonemic fluency among those with the same credential in particular. So there's still a lot of within group variation to explain, but the between group variation seems to be largely, certainly not entirely, but largely accounted for by achievements and opportunities in high school. This is a speculation. So this goes back to, like, Jen will appreciate this from the old Coleman report days, right? Do schools matter? We like to ask, do schools matter? So does this mean schools don't matter? No, it doesn't mean schools don't matter for a couple reasons. One, it may be that schools do not vary as much as people think they do. That is, schools are doing a lot of the same things. And so if we don't capture a lot of between school variability, it doesn't mean schools don't matter. It may also mean schools are mostly doing similar things. And so you can't, if you have less variation, you can't capture it. The other thing that I've come back to over and over in my career, but done little about, frankly, is that schools aren't the places where students are actually doing the most learning. They're doing that learning in classrooms. And we typically don't have good measures, certainly in the high school and beyond data, we don't have good measures of what happens in classrooms, the learning that happens in classrooms, the interactions between the adults and the students in the classroom, the climate in the classroom, interactions among students, right? And this happens from pre-K on up through high school. And that's the other thing. We're observing high school. So we're observing sort of almost the end of this dance, right? There's lots of education that has happened before we see students in high school. So I don't want you to walk away thinking Grodsky said schools don't matter. No, I'm not saying schools don't matter. I am saying there are other things about education within schools that probably matter a great deal and that we may underappreciate. So what's missing here, course taking is one of them. I've not shown you, to your point about calculus, for example, I've not shown you who takes those courses. We have that information. I will include in the future. I didn't show you now because that's a mix of opportunity and choice. And I was really trying to think about what are the opportunities students have and then what are their achievements. But that's on the way to somewhere else. So we'll get there. There are other dimensions of opportunity in schools you could think about, like academic press, the extent to which there's variability in course taking in the school that may be driven by school decisions, the extent to which homework is assigned, expectations are held. There's also variation potentially in the association between these attributes and cognitive function by race, ethnicity, by sex. And there's a sort of there's a continuously developing literature about racial and ethnic differences and the contributions of education to cognitive function, to cognitive decline over the life course that we will engage. And then also all the things you're about to suggest when I wrap up. I do want to plug again, and I appreciate Alejandro plugging this for me. EdShare, Education Studies for Healthy Aging Research. EdShareProject.org is where we live. There's a QR code. I don't know why there's a dinosaur in it. That's just what Chrome gives me. There's a QR code there. I'm happy to share this resource with you. It's got all this stuff on the education data and the high school and beyond data that's going to come out, and it's got stuff on NLS 72. I encourage you to look at it. And of course, thank you to the people who provided the funding to do this, National Institute on Aging, Alzheimer's Association, and our awesome population centers. So thanks very much.